In this video, we're going to talk about scatter plots. In particular, our desire is to connect this to something called linear regression. And as you can probably guess, we're looking for a linear relationship when we are looking at a scatter plot. So first, let's go ahead and do a little bit of vocabulary. So data in which two variables are measured on a single individual is called bivariate data. So they're both measured on the same individual, and that kind of pairs them together very intentionally. All right. So we're going to learn a couple of vocabulary words that actually aren't in this book, but are pretty significant and used a lot in statistics. That would be the explanatory variable and the response variable. So the response variable, that variable is the dependent variable, whose value can be explained by the explanatory variable. Which we could also call a predictor variable. It's typically the independent variable, and you might remember that terminology, independent and dependent, back from algebra. So let's look at an example. Which one would we think would make more sense to be the explanatory variable? The height of an individual or their arm span? Well, most people, when we think of humans, we typically think of them as getting taller, not so much as their arms getting longer. We kind of feel like the arm length is somehow directly connected to their growth in height. So most people would say that the height would be the explanatory variable. And the response variable would be the arm span. So we're interested in looking at a graphical relationship between bivariate data. And quick note, bivariate data is quantitative data. So we're talking about numerical data. And what we're interested in is representing that data as a single point, where that single point represents two pieces of information. Because every ordered pair is a pair of data. So we're looking for patterns. That's what we're interested in doing with the scatter diagram. And we want to look for linear patterns in particular. So kind of looking at these 6 graphs here, let's kind of compare and say, all right, so going through this, what do we notice about the first graph? First of all, I noticed that it does have a pretty good linear pattern. I mean, they vary a little bit, but I can kind of imagine a line, right? Going right through here. So this I would consider a strong linear pattern. But not only that, you might remember with lines, we also kind of tend to think of slope, right? How they're tilting. In this case, it would be going positive into the positive increasing direction. So we would say this has a strong positive linear relationship or linear pattern. Now, this seems to have a strong linear pattern. The problem is this like crazy little data value over here, which is clearly an outlier, but that does kind of cause there to be a problem when we look at a linear pattern. So I would say that this is a linear pattern, but we definitely have some sort of outlier here, and it's probably going to weaken the linear relationship. So sometimes they call that a deviation. But really, we're talking about some data value that's not really fitting the rest. Okay, so I definitely see we're going the other direction now. This is kind of has somewhat of a weak pattern, linear weak pattern, and it's going in the negative direction. So that's how I categorize this: a weak, negative, linear pattern. However, this one's much stronger, right? They're far more grouped together. So this would be a strong linear pattern. Oh, sorry, strong negative. We do want to kind of comment on the positive and negative elements. All right, now this one doesn't look linear. In fact, you might kind of recognize this pattern. This would be exponential. And there are studies of all the different types of patterns, exponential, quadratic, which is kind of a parabola, and all sorts of different types of patterns. But we're going to focus on linear. This last one, I mean, I wouldn't even know where to draw a line if I were to try to do this. So I would say there's no pattern at all to this. I mean, that's just kind of a random scattering of data, and I don't really see any sort of discernible relationship between that data. Okay, so let's go ahead and practice doing some scatter diagrams here. So we have this information, and I'm going to go ahead and just do a little picture over here and kind of give some guidelines to what I look for when I want to do one of these. So first, we need to make sure we label the X and Y axis. And earlier, I think I kind of glossed over it, but let me come back up here. There we go. The x-axis is the explanatory variable. So we want to make sure that the explanatory variable is what we're calling the x values. Now, in this example, they've kind of defined it for us, but it makes sense. The more you practice, usually the better you're going to do, okay, in a game. So hours of practicing, that's going to be our x-axis. And our y-axis would be the points scored. Now, the x values, it might make sense to go ahead and go by twos, since the largest value is 12. But it really wouldn't be a big deal if you went ahead and went ones. 12 little tick marks isn't too complicated to draw. However, I'm not going to do 36 tick marks on the y-axis. So I think going by fives is very reasonable for that. So I'll have to go up to 40 to make sure that I get all of the values. In general, you want to try to do at least 5 tick marks. Anything less and it starts to be just too little. Like I could have gone by tens, but that would have only given me 4 tick marks. And like I said, you want to typically do 5. All right, so I'm going to go ahead and graph this now. So 5 and 15 would be right here. 7 and 22 would be somewhere in between these two values. 9 and 28, closer to the 30. 10 and 31. Now, just so you know, values can repeat. It doesn't have to be non-repetitive. 11 and 33, somewhere in between here, a little bit higher, and then 12 and 36, even a little bit higher. All right, and there we go. So based on what we kind of looked at before, it does seem like there's a pretty good linear pattern here. They are pretty grouped together. So I would say that this has a relatively strong linear pattern, and it would be positive, going in the positive direction. We will have a way of measuring strength in the next section. But yeah, relatively strong, at least based on looks. Okay, so in this chapter, we are going to use technology. I'm going to go ahead and work with Excel, but all that I'm going to show you is going to also work in Google Sheets, and it's pretty easy to find information on how to do that. So this next example here, first we're asked which is the response and which is the explanatory variable. So when we're talking about colas and women drinking colas, and wondering if that possibly lowers the bone mineral density, kind of makes sense to say that the explanatory variable is the number of colas consumed, right? Let me go ahead and switch back to red. So this would be colas per week. And the response variable would be the bone mineral density. All right. Now, to do the scatter diagram, I am going to use Excel. And I'm going to cheat here and I'm going to copy this information right off of this table. So you may want to go ahead and open up Excel or Google Sheets and grab that information. Actually, I might show you how to do it on Google Sheets too. Let me go ahead and copy that. Yes, thank you. And I should have Excel opened, please. Yes, okay. Control V. All right. And then let me come back here and get the rest of the data, these two columns over here. I don't really need the labels. I just need the data. So I'm going to go ahead and come back here. Okay. And there we go. All right. Sweet. So there is my data. Okay. So in Excel, oops, if you want to do a scatter diagram, there are a couple different ways. Hang on. I'm going to hide something here that you guys can't see, but I can see. All right. So let's see. I believe, nope, not draw. Come up here. There we go. Insert. Okay. See how there's all these little graphs here? Let's find the one that looks like a scatter plot. That would be this one right here. And I'm going to pick the one that just grabs a pattern. And you see Excel automatically knew what to do. They did label or title the graph, I should say, based on the second column. I would actually come over here and include the axis titles. Usually you could type them in. Let's see, Control A, Control C. All right, let's do this. So that would be down here. Yeah, I know, thank you. And then I can label this one. I'm gonna actually grab this label. And label this axis. Wow, all right, can you decrease that? I'm sure you can. Wow, all right, that got all complicated. Let me come back here. Oh, wow, that was not what I meant to do either. I'm making a mess of this. Here we go. Home. Yes. All right. Decrease, decrease, decrease. That was so weird. You guys went that big. Try to make it look like the other one. There we go. All right. And then I probably titled this graph bone mineral density based on colas consumed. Based on, I don't want that in the parentheses. Colas per week. There we go. You might even refer to whatever the study is called, but there we go. And what's really nice is you could actually just grab the graph and bring it into, I believe, Word. I'll try that, copy and paste. Let's see if it works. I might wig the program out. Let's find out. Oh, there it is. Isn't that nifty? And it looks so pretty. And I squeezed it up so it's here. And there you go. Let me go ahead and I'll try doing this in Google really quick. Google Sheets, for those of you who like Google Sheets better or who don't have Excel. It's going to take me a second to load up. So if you need to forward through, that's fine. Forward through. All right, so let me go to Google Sheets. And I'm going to copy my data out of Excel. while that's loading. All right. There it is. Yay. Okay, so in Google Sheets, it might be the same exact area. Yeah, insert, and you see here where it says chart or image. Let's go to chart. I believe that's what we're actually after. And it should give us some options. It's just thinking. Here we go. Okay, so it kind of took its best guess. I'm going to come over here to chart type and I'm going to select that. All right, now notice that Google Sheets, it kind of automatically starts its y-axis at 0. But because all the data is grouped up, we may want to go ahead and change the y-axis. And let's see, I believe I can fix that. Oops. Here's where you could fix the axes labels, which Google did a great job on that. Oh, here we go. Horizontal axis and vertical axis. Okay, so minimum number. So I looks like I at least want to get to 0.75. Oh, even shorter. Okay, so 0.85. There we go. That looks really good. Okay, and we should be able to pull this graph too. You should be able to copy and paste. And you could see Google actually did the axes a little bit nicer than Excel did. It knew what to grab. But it did make a bad guess on which chart you wanted. So you did have to do some fiddling around with it in either case. But there you go. That's how you can do a scatter plot on either Excel or Google Sheets. Did it stop recording?